Good morning student. In this session we will study the design of leaf spring. It is also known as carriage spring because it is used as a suspension system in automobiles. First we will study the figure, the details of the leaf spring. This is the figure of leaf spring. This is known as master leaf or main leaf having eye. Now this is extra full length leaf, or below the master leaf the extra full length leaf is there, and after that graduated leaves are there. These are graduated leaves, and these are U-bolts, and this is central bolt. This is rebound clip. Now we will go through the nomenclature or different length of the springs. Length of leaf spring leaves. Let 2L1 is equal to overall length of spring or span length in millimeter. This length, the distance between the centers of two eyes, is known as the span length, and that is equal to 2L1. Now 2L is equal to effective length of the spring in millimeter, and L is equal to width of band or distance between U-bolts in millimeter. That is this length. These are U-bolts, and distance between these U-bolts is small l. That is ineffective length in millimeter. Ng is equal to number of graduated leaves including master leaf. Nf is equal to number of extra full length leaves, and N is equal to Ng plus Nf, that is equal to total number of leaves. Now effective length, that is equal to 2L, that is equal to 2L1 minus L, where band is used, and in case where U-bolts are used, the effective length is given by 2L is equal to 2L1 minus 2 by 3L. Length of smallest leaf, this is the smallest leaf, is equal to effective length upon N minus 1 plus ineffective length. This is ineffective length. So this is equal to 2L upon N minus 1 plus L. Length of next leaf, this is the smallest leaf, and the length of next leaf means this one. The length of next leaf is equal to 2L upon N minus 1 into 2 plus L. Now length of N minus 1 leaf, 2L upon N minus 1 into N minus 1 plus L. Now length of master leaf or main leaf, this is the main leaf, master leaf, equal to 2L1 plus pi in the bracket D plus T, bracket is complete, into 2. Now D is the inner diameter, D is inside diameter of eye, this is inside diameter, and T is the thickness of leaf, T is the thickness of leaf, and 2 pi D is the circumference, of this eye. So the length of master leaf or main leaf is equal to 2L1 plus pi D in the bracket D plus T into 2. Now Ng is the number of graduated leaves including master leaf. Nf is equal to number of extra full length leaves. N is equal to Ng plus Nf is equal to total number of leaves. B is equal to width of each leaf in millimeter. 2L is equal to effective length of leaf spring in millimeter. L is equal to semi-effective length of the leaf spring in millimeter. 2F is the force acting at the center of the spring in Newton. F is equal to the force acting at the ends of the spring in Newton. At the ends in Newton. Sigma BF is the bending stress induced in full length leaves in Newton per millimeter square. Sigma BG is equal to bending stress induced in graduated leaves in Newton per millimeter square. Delta is equal to maximum deflection of leaf spring in millimeter. K is equal to stiffness of leaf spring in Newton per millimeter. Now design of leaf spring without nipping. You can say leaves are not initially stressed. The bending stress induced in full length leaves is 50% greater than the bending stress induced in graduated leaves. This leads to non-effective utilization of graduated leaves. Now for these conditions, the formula used are: first, the bending stress induced in full length leaves, sigma BF is equal to 9FL upon in the bracket 1.5 NF plus NG into BT square, and sigma BF is equal to 1.5 into sigma BG. Now second, the maximum deflection of leaf spring due to central force 2F, delta is equal to 6FL cube upon in the bracket 1.5 NF plus NG bracket is complete into E into B into T cube. Third, the stiffness of leaf spring K is equal to F upon delta, that is equal to in the bracket 1.5 NF plus NG bracket is complete into E into B into T cube upon 6L cube. Now next is design of leaf spring. All leaves are equally stressed or without nipping. When leaves are pre-stressed by nipping, generally all the leaves are equally stressed. Hence, in such case, the bending stress induced in full-length leaves is equal to the bending stress induced in graduated leaves. This leads to more effective utilization of the material. In this condition, first, the bending stress induced in full-length leaves or graduated leaves, sigma is equal to sigma BF is equal to sigma BG is equal to M upon Z, that is equal to F into L upon 1 upon 6 N into B into T square, that is equal to 6FL upon N into B into T square. Second, the maximum deflection of the spring due to 2F is given by delta is equal to 6FL cube upon 1.5 NF plus NG bracket is complete into E into B into T cube. Third, the stiffness of the leaf spring is given by K is equal to F upon delta, that is equal to in the bracket 1.5 NF plus NG bracket is complete into E into B into T cube upon 6L cube. And initial nip is given by C is equal to 2FL cube upon E into N into B into T cube. The load on the spring band when assembled, that is preloaded, Fi is equal to F into Ng into Nf upon N in the bracket 1.5 Nf plus Ng. So this is all about the design of leaf spring when initially stressed, and second, it is not initially stressed. So Here in this session we have studied the details of leaf spring, nomenclature of leaf spring, and different types of lengths of the leaf spring, and the list of different formula used for design of leaf spring. Thank you very much. This is the end of the session.